All right. So thank you. Good morning. And thank you for including our paper in the program. And it's a great honor for me to open the conference as the first speaker. Today I will talk about a new method for factor construction in asset pricing. This is joint work with Will Cong from NTU in Singapore and Chunyu, my former PhD student, who is also here today. Okay, so let me start with the big picture. So the central question in asset pricing is why do different stocks earn different average returns? And the APT provides a risk-based explanation. According to the theory, securities earn higher expected returns because they are more exposed to systematic risk factors. The main challenge in empirical research is what are these factors? Okay, there is very large literature trying to answer this question. And broadly speaking, existing methods fall into two categories: observable approach and the latent approach. The earliest latent approach, going back to 1980s, applies PCA to individual stock returns. While statistically convenient, the factors are difficult to interpret statistically. The most popular approach in empirical asset pricing is the solid factor approach, or well known. So factors are constructed by portfolio sorts and the long-short strategies. Each factor typically relies on one or two pre-specified characteristics. So the factors are easy to interpret. So this is a major advantage. Okay. So the main issue with this approach is that it may suffer from the well-known factorial issue. So recent advances in the latent framework are applying PCA to a large number of characteristic sorted or managed portfolios. These include PCA factors, RPPCA factors, and IPCA factors. Okay. So while these methods help obtain the factor zoo, the resulting factor are typically dense linear combination of all portfolios, which again make economic interpretation difficult. Right? So this paper introduced a new factor construction method, which we call economically guided sparse factors, or EGS factors. Okay, to be clear, it's not a typo for ESG. Okay, so we are not scoring firms on green stuff. We are using economic theory to keep the factor design sparse and economically meaningful. Okay, so here is the main idea. So we start with a standard statistical PCA framework, but we don't want to optimize only for statistical fit. We also care about the two other critical dimensions: economic interpretability and asset pricing performance. Okay. Our EGS factors aims to balance all three. Okay, so this is the main picture of the paper. And specifically, we propose a sparse PCA framework with economically guided sparsity selection. So in fact, it turns out both observable factors and the latent factors emerge as two nibbling cases of our framework. So in the sparse limit, we obtain data-driven observable factors. And in the dense limit, we get back to standard PCA factors. Okay, this is how we position our paper in the literature. So the EGS idea can also be extended to RPPCA, but for today's presentation, I'm going to focus on the baseline PCA version for simplicity. Okay, so this page provides a comparison of the methods across three dimensions, as I just mentioned. So economic interpretability, co-movement capture, and asset pricing performance. Okay, so the last one, okay, EGS factors. Our EGS factors offer economic interpretability similar to observer factors, and capture co-movement closely aligned with the PCA and the IPCA factors, and significantly outperform both in terms of asset pricing performance. Okay, so the key advantage here is the integration of economic theory, which guides the construction of our methods, of our factors. All right, so let me now introduce our baseline EGS factor construction. Okay, so we start with a set of basic portfolios and a factor model. Okay, so we are in latent factor model framework. So the central question here is how to construct factor loadings. So a standard approach is PCA. In standard PCA, factor loadings are constructed to maximize variance explained in XT. Okay, while this method works well statistically, right? Many good properties are there. The resulting factors can be difficult to interpret economically and may lead to overfitting when capturing co-movement. So to address these issues, we introduce sparsity into PCA factor construction by imposing sort of lasso type penalties. Okay. But the key innovation here is we use economic constraint to guide the selection of the sparsity level. Okay, so this is the key innovation. No worry, I will come back to talk about economic constraint, okay, soon. Okay, so here's our basic portfolios. Our basic portfolios are constructed by Feynman backpath regressions. Okay, so there are several reasons for why we're using these portfolios as a building block of our factor construction. So of course, the same idea can be applied to sorted portfolios, but here we focus on these portfolios as an illustration. Okay, so there are three main reasons for why we're using these portfolios. So first reason, these portfolios are highly interpretable. So ZT-1 here is the data matrix for stock characteristics. And we have constant there as the first column, and the other columns are standardized to have been 0. Then in this case, we can show the first portfolio in XT is a market portfolio, equal weighted market portfolio. And the other portfolios are pure plays. Other portfolios have 0 cost. Each of other portfolios is a pure play on one characteristics. And second, so these portfolios are optimal in certain sense. So they are maximally diversified portfolios. This is a classical result going back to Feynman 1976. And this is related to efficiency of oil estimator in linear regression. And lastly, a recent paper by my co-author and me shows that applying PCA to these portfolios provides an econometric estimation of conditional factor models. Right, so before showing the full empirical results, let me give a simple illustration of two key components of paper are very important. So sparsity and economic constraint, right? So I will use two graphs, this one and this one, okay, to make the idea transparent. Okay. So the first graph here shows how to explain the variance and the swap ratio of the first factor change as we vary the sparsity level. So X as here is the regularization parameter lambda. A larger lambda corresponds to a higher sparsity level. So from the left to right, we have dense to sparse. Okay. So the blue curve shows the explained variance, and the red curve shows the swap ratio. Okay, as we increase the sparsity level, the factor naturally explains less variance. This is easy to understand. Okay, as we increase the sparsity level, so more weight is placed on the sparsity penalty, right? However, increasing the sparsity level does not always lead to an improved swap ratio. Okay, then you may ask why and what happened. Okay, let's move to the second graph. Okay, the second graph here shows the factor loadings at 4 different sparsity levels. Okay, the first one, PCA. Okay, factor loadings and the 3 sparsity levels are marked in the first graph, right? So y-axis here presents different portfolios associated with different characteristics. And there are 2 colors as well. Oops, sorry. Okay, sorry, this one. So there are 2 colors as well. So red one and the blue one. Okay, so red bar corresponds to portfolios with positive expected return. So for example, the first portfolio here is market portfolio. Okay, so its average return is positive, so the color is red. And the blue bar corresponds to portfolios with negative expected return. So economically, we like to go long on portfolios with positive expected return and the short on portfolios with negative expected return. Okay, so this means ideally red bars should point to the right and the blue bars should point to the left. All right? And this is where PCA falls short. Okay, PCA factor loadings are dense and contain many offsetting positions. Okay. So increasing the sparsity level helps to eliminate these positions, okay, those offsetting positions, though it may reduce the swap ratio. As we observed in this graph, okay? By applying economic constraint, we can ensure that the factor maintain a high swap ratio. Then the resulting factor at the last sparsity level refers to our first EGS factors, the market factor. Okay, let me explain the economic constraint more clearly. Okay, we require each factor to take long positions in managed portfolios with positive expected return and short positions in growth with negative expected return. It turns out this idea closely echoes the spirit of Pharma French 1993 long-short idea. So their factors take strong positions in sorted portfolios with high expected return and short positions in those with low expected return. And both approach leverage the monotonicity of characteristics predictive power for average returns. Okay, so by imposing these constraints, we ensure that every selected portfolio contributes positively to the factor's risk premium. And this avoids offsetting positions that could dilute its mean variance efficiency. Okay, so here we impose monotonicity, and imposing monotonicity is just one illustration of integrating economic theory into factor construction. So other forms of economic theory, such as the implications from APT used in RPPCA, can be applied to guide the factor construction. So let me briefly describe the data set. So we use US common stocks between 1973 and 2022, and the characteristics from the open source data set by Chen and Zimmerman 2022. By standard data cleaning and processing, we retain 52 characteristics, or 53 if the constant is counted. Okay, so these are our first empirical results. So this page shows our first EGH factors. Okay, so each factor here is sparse and loading on at most 3 characteristics. So they are easy to interpret. Okay, more importantly, none of these factors involve offsetting positions. Every selected portfolio here contribute positively to the factor's risk premium. So all red bars are pointing to the right. All blue bars are pointing to the left. And the first factor is the market factor, as I just explained. And the other factors are associated with several well-known characteristics in the literature. For example, the second factor is associated with momentum, and the other factors are associated with profitability, liquidity, a shorter reversal. And probably it's hard to see, you know, the y-axis, the name on the y-axis here. And the last factor is associated with R&D. Okay, for comparison, these 2 pages also shows the PCA and IPCA factors. So as you can see, all these factors are dense and difficult to interpret, okay, with many offsetting positions. Okay? And this highlights the key difference relative to our EGH factors. So this page shows the outsample swap ratio of the tangency portfolio. Okay? So our EGH factors have significantly higher outsample swap ratios than both the latent and observable factors. So no matter actually what is the number of factor we take here. So for example, so our first 6 EGH factors achieves an outsample swap ratio of 2.04, which is much higher than 0.97 for PCA factors, and 1.57 for IPCA factors, and 0.95 for pharma-French 6 factors. Okay, so this page shows the results of empirical asset pricing test by using 3 sets of test portfolios. So our EGH factors outperform both the latent and observed factors in terms of smaller pricing error. Okay. So for example, when explaining pharma-French 100 solid portfolios, our EGH factor reduce the outsample root mean square alpha to 0.23%, lower than 0.76% for PCA factors, 0.57% for IPCA factors, and 0.34% for pharma-French 6 factors. So that's all the empirical results I want to share. So let me conclude. So this paper proposed a new EGH factor framework that combines the strength of both latent and observable factors in empirical asset pricing by introducing sparsity into PCA with economic guidance. We strike a compelling balance among 3 key dimensions: economic interpretability, co-movement capture, and asset pricing performance. Okay. The EGH approach mitigates overfitting in both factor construction and risk premium estimation and provides a unifying, economically disciplined perspective on the SDF. Thank you, and I look forward to your questions.